section we can discuss about in the chapter of second year physics syllabus, fourth one, electric charges and field. So in previous class we can learn about the Coulomb's law in electrostats, and next one electric field intensity due to a point charge. Then third question is electric dipole, define electric dipole, and next one we can determine the couple acting on the electric dipole will be placed on the uniform electric field. So our topic is first one, how we can define electric dipole. So what is electric dipole? So the electric dipole is represented by P. So in this one as well we can represent the electric charge is Q. So in electric dipole we can take the two charges, so two equal and opposite charges. So now we can take the two equal and opposite charges. So this is the minus Q charge and this is the plus Q charge. So two different charges and equal charges but opposite charges. So these two charges are separated by a distance. The distance is 2a. So two equal and opposite charges are separated by a distance. It is called electric dipole. So two equal and opposite charges. Equal means Q. Opposite charges, negative charge and positive charges, separated by a small distance. The distance is 2a. So the arrangement is called electric dipole. Now we can write the formula of the electric dipole. So the electric dipole is represented by P. So P is equal to 2a into Q, means electric dipole P. 2a means distance between the two charges, and where Q is the magnitude of the plus Q charge and minus Q charge. So this is the principle for expression for the electric dipole. Now we can write the SI units of the electric dipole. So what are the SI units? Where 2a is the distance, so the distance are measured in meters. Now we can write the meter into Q means charge, electric charge will be measured in coulomb. So meter coulomb is the SI unit of the electric dipole. And next one we can determine the electric dipole value. When the electric dipole will be placed on the uniform electric field, now we can determine the torque couple acting on the dipole. So let we can take the what I am saying here, electric dipole. So couple or what I am saying here, torque. We can determine the couple or the torque when the electric dipole will be placed on the uniform electric field. Now we can take the figure of the electric dipole will be placed on the uniform electric field. So this is the electric field. It will be represented by E bar. And now we can take the electric dipole will be placed on the, so this is the electric dipole. So the electric dipole means it will be have minus Q charge and plus Q charge and separated by a distance 2a. Now the angle is made with the electric field. It will be represented by theta. So this is called perpendicular distance. Now we can take the electric dipole. When we can take the electric dipole will be placed on the uniform electric field. So the angle between the electric dipole and electric field is represented by theta. Now we can take the definition of the electric field intensity. So force acting in the, what I am writing here, force acting on the plus Q charge is equal to plus EQ. And next one, force acting on the minus q charge is equal to minus eq. Now we can write the force acting on the plus q charge F is equal to plus eq, and force acting on the minus q charge F is equal to minus eq. So when we can observe this electric dipole, the two forces are equal forces. So the net force on the electric dipole will be 0. So two different charges, it will be constitute the torque in the electric field due to the electric dipole. So now we can write the torque. So the constitute torque, produced torque, tau is equal to perpendicular distance into magnitude of the force. Tau is equal to R cross F. Now we can write that tau is equal to, where R is the perpendicular distance. So this is called perpendicular distance. So the value is 2a sin theta. So where we can take the 2a sin theta. So this is the theta, perpendicular distance. So sin theta. So according to trigonometric function, sin theta is equal to opposite side by hypotenuse. So now we can write the opposite side is the perpendicular distance sin theta, where we can take from figure sin theta is equal to opposite side by hypotenuse. So sin theta is equal to opposite side means perpendicular distance by hypotenuse means 2a. So opposite side is equal to, we can write the 2a sin theta. So where OP or 2a sin theta is called perpendicular distance. So tau is equal to, we can write 2a sin theta into, where F means F is equal to plus EQ, F is equal to minus EQ. We can take only magnitude of the force. So now we can write EQ, and tau is equal to 2a into Q. Now we can take that in the bracket, and remaining terms of E sin theta, and tau is equal to 2a into Q, P. So P E sin theta. So tau is equal to, we can write P cross E. So this is the final equation. So where we can take the equation tau means couple acting on the electric dipole, or torque acting on the electric dipole. So torque or couple acting on the electric dipole when the electric dipole will be placed on the uniform electric field.